Good morning, good afternoon, hello. I'm back again and I'm going directly back to work because, yeah, we have a lot to do. I hope everything is okay. I'm not on mute. That's okay. Nice. So the message from last week for my today's self is decoupling caps for the memory and GND ground vias and VDD connections. So that's a task number one. The task number two is regular local routing of the other blocks. Okay, that's general requirement of all the PCB layout. Make the free space track 0.09 okay, or thinner or wider, not thinner, definitely not thinner, wider. But I think much more wide, much wider, because 0.09 is 3.5 mil, and it's a minimum track width, and the regular signals like almost everywhere besides the USB and USB in this case. And do we have Ethernet? Yes, we do. So there are some 100 ohm impedance controlled lines which will be defined or already are defined here. Both of them will be 0.09, 3.5 mil, but the other ones will be predefined sizes 0.2, 3, or 5. That's my go-to track width. 0.3 is like an ideal balance between narrow tracks, making easier routing, and current tracking capability, like not so thin, not so sensitive to anything, more manufacturing process, let's say tolerant, many things. 0.3 is my go-to. 0.20 is okay, 0.25 nice, 0.3 my go-to track width for regular designs. I'm tuning over to comments for me, not for you, for me. Okay, no comments yet. Today I realized that sometimes I usually should be replaced with always or never. Can see it because my face is over there. So yeah, there is so many things I need to take care about during the streams that sometimes I miss a thing or more. The message was clear, decoupling caps, but during the rest period since the last stream, I realized that the routing is far from perfect, and I should at least try to focus on some weak spots. And the weak spot number one is here. Yeah, that's bad. That's bad routing, weak routing. So how to avoid this via and 1 millimeter wide or long tracks on the inner layers? Let's check this pair. Yeah, It goes directly from the MPU. Yeah, I think more spots on the PCB is far from optimal. Even this entire area, yeah, I don't like it much. We will see. There will always be space for routing here because probably none of other tracks on top layer will be in this area, so I can definitely change this, and I should make a mark for my future self that the target length is 34.4, let's say, to be precise. I think definitely a little bit smaller. Yes. The clock, yeah, 34.4. Yeah, it's easier to find out, but yeah, there is a note for me when I will be working on that. Back to this track. Yeah, this one makes me nervous, makes my hair being stitchy or itchy, anything. Yeah, the ideal would be to keep it on the top layer only. It's DQS. Yeah, DQS, it's I think a strobe signal for a lower data byte, and this signal marks validity or validates the data on the lower data bus byte. Quite important. And obviously we have two options: to keep the DQS on the top layer and use 2 extra vias or 4 extra vias for the DQ7 and DQS. What can we do else? This is the pair, and here is the signal, which is naturally below. Here is this one. No, above. Yeah, naturally above the pair. Can I go below the pair with the signals, which would solve the issue? Solves or not? Yeah, it would, because I would go from the right side, and then yeah, it will solve the issue. It would solve the issue. So what else? What else can we do? This is the pair. And here are the tracks which what's this? Yeah, we have to take care about the KiCad performance when measure. Yeah, now. Yeah. So above. How to go below? Without vias, of course, because when I use vias, it's easier. Question: are all our data bits routed only on the top layer? It seems they are. Yeah, only. Yeah, which meets the initial requirement. Yeah, green and red signals on top. Okay. There is probably nothing I can do because the pitch is too narrow and the area is too crowded. So what I can do is to use 2 extra vias here. So it means well, yeah, I wish KiCad keep the setup of the copper layer pair, but yeah. I think I can go wider here, yeah. Yeah, sometimes this happens, I don't know why this happens. Okay, too long. So we have to tune this segment, number 6 and number 7, yes. So as we trained last week, Yes. And we have 30.4.4 single-sided. Yes, this is the verified set of numbers. And let's go. And the same here. I would like to go, not to go, I would like to start here. It's not always. This is not bad. Okay, so well, now the pair is too short. Why? Yeah, because there were vias, and it counted not so much. The distance between top and inner two is like 0.5 millimeter, twice. Yeah, can be. Okay. So it changes the situation. It changes the situation because we have to take care about this pair. Okay. So I will remove this, move it a little bit upper. Yes, as I said at the beginning of the show, this area is subject to change. And now it's the time. So now the pair. Yes. Yeah, I want it double-sided. Exactly, double-sided. 0.6 I think works well, and spacing is fine. Okay, so let's see. Let's see what can we do. Somewhere in the middle. Yeah, I think not bad. And the rest of the signals here. Single-sided, yes, and somewhere here. One more, and a little bit taller, perfect. Now the target length. One more. Yes. What here? Yeah, it's almost fine. I think 2 or 3 is. Yeah, this one. One more. 2 more. No, too narrow. A little bit higher here. Here, 34.4. Yeah, again here. One more, a little bit taller. No. Yes. Okay, so I will start more in the like this, and this one like this. I don't know. Hello, thank you. Thank you, Abdullah. Thank you. Thank you for being here. Okay, I will keep it like this. So, we have solved this by protecting the pair, but the data lines are affected, but I don't think it will have such an impact. Oh, okay. Okay, and the skew. What about the skew of the signal of the pair? 0.5 millimeter. So this one is too long. Yeah, this one must be longer, 0.5 millimeter. Okay, so let's tune to 0. Single-sided, 0.6. Yeah, this one is good. Okay. Okay. Understand. It doesn't want to. Okay. So again. Here. The other signals. 0.7. This one is too long. No, too short. Okay, so let's try. Good. And the last pair is here. 0.57. This one is too short. Yeah, this one is too short. Yeah, I'm looking for a better segment for length tuning. Okay. Let's get to the caps. Is there any chance to place some of them on the top layer? I think all of them here. Which makes the future manufacturing easier. This is a resistor, isn't it? Yes. Okay. Yeah, this is the divider, resistor, yes, and capacitor. So I will put them here. Ideally, the capacitor should go closer to the pin or pad, and the divider resistors can go further, but yeah, I will keep them for now in the line. Just for pure aesthetics, I will move them or place them aligned, and this one an outlier, yeah, a little bit closer here. Even this one can be closer. Okay, like this. Okay, good. And these ones, not these ones definitely must be on the bottom layer, unfortunately. This one as well. But I think, yeah, 04, 02, okay, it's not so small. This is 0, yeah, all of them are 04, that's fine. 04 is manufacturable. Yeah, what concerns me are these 02, 01, yeah. Ideally, I would change all of them to 04, 02. If would be at least slightly, or yeah, I think it's barely possible to change all of them, but it would make me happier because the further manufacturing will be much easier. Why? 02, 01 are too small, and those pads are too small that the stencil needs special treatment to print the solder paste evenly. And in my environment with my tools, it's not so easy. And if you print the paste not evenly, it will cause manufacturing issues, like one of the side will melt faster and have bigger thermal capacity than the other one, so it will make the so-called thumb stones, or rotation of the components, or everything that you definitely don't want. So some of the caps here can be placed on the top layer. I don't know if it's a big deal. Oh, why not? Oh, this one. Yeah, the mathematics is simple. The more components on the top layer, the happier I am, because it means single solder paste print, single component placement, and what's more important, single reflow soldering. Because if I print and place components and solder components on one layer, then I have to flip the board, print again, place component again, and reflow again. And yeah, naturally, you understand that double reflowing means that the component can move, that can rotate, that can thumbstone, anything. Zero 0402s are okay, even for my eyes, which, or sight, which is getting weaker, but still okay. But 0201 are too small that even holding of the component in the pair of tweezers is a pain in the fingers. Yeah. As I can see, this group, I'm saying to myself, why to make the group so strange. So half of them on the top, half of them on the bottom. Yeah. I'm removing this dichotomy because, yeah. Now I think none or all. Yeah. Sometimes it allows me to remove the via. Yeah, I think it's better. Why I'm placing the via here for interconnection with the other ones. This one. This one. Ah. No, no. Oh, okay. Yeah, I should place the copper pores on the inner 2 and inner 4, which will be grounds. For solid, yes, nice. Wait, this, we already have this. Hello, yes, I can, for about 350% price increase. If you place vias beside the pads, the vias are filled with epoxy and capped. And then if you want to use the vias in pads, the vias must be filled not with epoxy, but with copper, then plated, and then it works like a via in pad. So 350% price increase. Yes, so that's why I am trying to avoid vias in pads, because it's too expensive. Joke. Yeah, this is how the dragging feature works. Yeah. Last week I reported my first KiCad bug or request for a fix, and every time I am using KiCad for professional work, I hit some. Oh, I won't continue. KiCad is great, but version 10 is filled with bugs, and probably nobody cares about them. And I think there is one reason. Nobody from the development team using it. Yeah, that's a great technology. Of course, VS in pads are the easiest for routing because it takes 0 extra space on the component layer, but yeah. Of course, it's a prototype and I can pay 4 times higher money for it because it's a single piece. Yeah, I will receive 5 pieces because I will be go there at GLC PCB. But still, yeah, I bought a component for like 150 euros, and not all, just the MPU, memory, and a few small things. Then the expensive PCB. So yeah, I try to keep the expenses low. I understand. Yeah, the grounding on the bottom side will be done by copper pour, most likely. There is no space for vias, and I don't want to overcomplicate it. What do these blue crosses means? Oh, this. I accidentally hit the flip function over the segment of the PCB of the track, and it immediately goes to the opposite layer defined here in the copper layer pair. So yeah, this was the reason. Okay, so now the coupling caps below the MPU, which makes me crazy. Well, I should start with the fanning out of the MPU pads, because then I will see what can be done. Or I can go per part test. For instance, this one I think can be moved over here. Yes, this one will be changed to 0402. Which is, let me see. In the memory there are some here, 225, okay. Oh, definitely. Yeah. I lost this one. C99. I checked the capacitor in the DDR block to use the same model, because I want to avoid nonsenses in BOM. Of course, you can and you should optimize the BOM afterwards, but yeah, the less attention now, the more attention now, the less attention in the future. Okay. Yeah, exactly. Yeah. Exactly. You hit the nail. Yeah, that's always an issue, because as I said, I'm using KiCad 8 hours a day, sometimes more, sometimes less, of course. And it's always difficult to stop working, isolate the bug, fill the report, share some screenshots, ideally videos, to reproduce the thing. Sometimes it's ideal to share the project itself, which I'm not allowed because it's a customer project, again and again. So yeah, exactly as you said. Yeah, what makes me crazy is this. Yeah, you route the track and I'm on the finest grid, and you can't finish the track without the extra segment at the end. Yeah, so you have to stop and delete it. One or 2 clicks more than minimal. I don't know why. Yeah, this fanning is just a draft routing, because I don't know what's the ideal sequence at the end, but just to be sure that there is enough space on the bottom. It's getting dense. The fact of fanning out of these BGAs is that you usually fan out 2 levels, like level 1, level 2, without problems, but the 3rd level usually needs a via, usually. What's this? Unused. Okay. Yeah, I'm thinking how to avoid deleting the extra segments. Maybe this way, keep them and mark them and delete them in one go, probably better. I don't know if it was worth the time, but yeah, I did. Thank you for tagging your friend. Thank you, Ahmad. How are you? Oh, I'm sorry. I forget to start the key screen. Does it work or not? No, it doesn't work. It doesn't work. Why? Oh, that's software quality these days. It doesn't work. Oh. Okay. Decoupling caps. So I think this one can be 0402. There is enough space around. So these two, I can see only one. Oh, next to each other. Okay. Change symbols into this one. Yes. Okay. Change. Okay. Yeah, this is entire group. Not this one. I think this was too soon, because there is a potential to change this one to the bigger package as well. Like this. Yeah, I have to keep this one horizontally because of these two vias, but never mind. Yes, yes, it can work, yeah. Or this one. There is a cluster. Now I have to make some routing because I need to know where the vias will be placed. Yeah, I will keep it like this. Not optimal, but yeah, we will see. We will see. Maybe not this way, but yeah, I think it will be okay. Yeah, this cluster makes me. Okay, so let's continue a little. Okay. I will not propagate the LCD signals, as you can see here. None of them is used, so I can rearrange the default position of the caps, which was taken from the reference design, something like this. But back, 2 steps back, because these suckers are 0201, and I don't want them. This one, and the second one is this one. Yes. Nothing like that. What's this one? Okay. The same distance. Okay. There will be some extra via, but yeah, for now it's okay. And now we have like a zillion other small caps, but not so much. This is what? This is oscillator. Yes. Yeah, this is part of this oscillator thing, okay. Yes. This is what? Okay. Bottom, okay, okay, can be. I think I will rotate it a little. This way. Okay. I have to take a break because I have to go to the service room. So in 30 seconds I will be back. I'm back and we can continue. So what else on the bottom? This cluster. I will fight for this one. I will try. Not optimal, but doable. So I think even this one, yes. This is like single-ended, yeah? Yes. I mean, not decoupling, but just output cap for some inner regulator or something. Yeah. Yeah, something. I think this is optimal because it takes quite a space. Because of this VA in between the pad. What's this? That's reset? No. VBAT. Okay. That's VBAT. Yeah. VBAT is not so fast. That must be placed closer or as close as possible to the pad, so I moved it further. This one. Yeah. My ambition is not to change all of them. Yeah, that would be ideal, but yeah. The more the better. Yeah, I should continue with the signal propagation here. I have to go. Oh, wait. This one can go here. Yeah, I know that this goes downward and this goes upward, but both are slow signals, and the ground via here is more important. Yeah, this is the second one to the pair. It's a PMIC I2C, so it's good to keep them in a pair. this thick. Maybe like this. Yeah. What's this? Yeah, it's already populated. What, this is the bed? Yes. So maybe this way. Not optimal, will be tweaked a little, but for now it works. Hopefully. What else? Yeah, the one thing, I kept all the signal descriptions for the unused signals. Here you can see all nets are labeled with the no connection mark, and that's good because next time I will know what can be used on that particular pin. Of course, there are multiple alternative functions, but what I want to say is that if I wouldn't, now I had the X mark on the pad, which makes the routing much easier. Yeah, of course I can help with the presence of the air wire, but the X is like X, yeah, no connection, no discussion. This is shared cap, why? I think in this situation I can even okay, I will not. Yeah, again, will be tweaked after, but for now it works. Button. The oscillator, this thing. Okay. It collides with the what's this anyhow? Anyway, CPU on. Okay, so we'll need a VRA here, yes. This is a signal for test point, so can be routed through here. Programming. My thing is creating a guard around the crystal. Oh. Okay, now I know how much space will I need. No. Okay. Okay. Gonna work. Now the caps. Back to the caps. Ground VDD core. Okay, so these two will be 0402. Ideally, I would place this one in between. Mhm. Yeah, this cluster, maybe closer. There is a cluster of pads that must be covered with these two decoupling caps, which will be doable, but with more of them and getting shorter of space. This is the ground via area here. So how to connect them? No. This is good, but too close. I need more space for the via. I think this cluster can be handled by the caps placed here. Oh, what did I do? What the fuck? I'm sorry. No, this violates the DDR, but it's not a big deal. No DDR, DRC. Okay. Hello. Oh. I forgot this. Okay, a lot to do, but I think for the next week. You know what? I will change all of them to 40402 at once, in one go, and then I will rearrange the entire situation. Not a good idea, because I immediately lose the immediately lose the situation, like situation awareness, I would say. These gaps are crucially important. But we have to lose one. My intention, I changed the 1 micro to 2.2 micro because I suspect this will simplify the BOM, and this one. Okay, it's not finished yet, of course, obviously, and will not for a long time, but it seems that we get rid of all the caps on the bottom, and it seems that yeah, it seems that it will work fine. I want to say that yeah, you saw me removing 2 caps because of the space constraints, but now I am adding 1. And maybe I will add 1 more. Yes. And now I want to check the BOM before I conclude the session. If there are still some 0201 components. Is it working or not? Yeah, is it, but on the other display. Footprint. Yeah, I think we are clear of 0201. That's great. That's definitely great. Great success for today. Yeah. It will be much easier to manufacture. Yeah. Now I'm not scared of it. And I was before. Yeah. It's not so crowded. Of course, it's not finished, but it will be fine. It will be fine. Yes. Good. I'm happy for this session. It was successful. A lot of work done. A lot of work in front of us, but it's about life, yes. Let me say something. I don't want to repeat myself, but you want, if you want to support me, I created 2 courses at fedevel.com, KiCad for beginners and KiCad for makers. It's ideal if you want to start with KiCad, KiCad for beginners. You will design this switch mode power supply from zero. Symbol creation, footprint creation, 3D models, component, schematic capture, everything is there. And you will get to the point you have manufacturing data for this switch mode power supply board, and there is a special promotion at nextpcb.com. If you enroll the course, you will receive a free coupon for PCBA assembly at nextpcb.com, which is valid for both courses. And this value, the coupon value is about $100 US dollars, and this, I don't know, half of them or something like this. It covers the components and the manufacturing cost and the PCB, bare PCB cost. Both courses at federal.com. And yeah, if you want to support me, this is the best way. So today's session, it was fun. It was fun day Friday. We changed all the caps from 0201, which scared me, to 0402, which don't scare me at all. Yeah, let's say at all. Yeah, at all. Because these components can be soldered even manually. I don't want to do that, and I will not do that, but yeah, can be. But 0201 are real suckers, believe me. So next week I will continue with the decoupling caps below, which makes me think about the note for my future self, which will be on September. Tuesday is 1st, 2nd is 4th. And decoupling caps for MPU and regular local routing is valid. Okay. Now I'm finished. Thank you for being here. Thank you for watching. Thank you for all the comments. And see you next week. The same time, maybe a little bit longer session. We will see. 2 hours and 6 minutes today. Not short, but yeah, an average length. See you next week. Bye.